Okay. And welcome to this week, second last session that we're gonna have. We're going to look at correlation and regression, and I can see that already we've taken a lot of time. And then on Saturday, we will do the chi-squared, and then we are done. Okay, so by the end of the session, you should at least know how to interpret and how to calculate the coefficient of correlation, and also how to calculate and interpret the coefficient of determination. And you should also be able to know how to find the regression line or to calculate the slope and the intercept of your regression. And sometimes you need to also know how to interpret them. Okay. So when we talk about correlation and regression, they are almost linked to one another. You cannot do one without the other. They both talk about the relationship between two numerical values. So correlation talks to the relationship, as well as the strength of that relationship, and you can also visualize it in a scatter plot. So you can look at how the two numerical values are related using a scatter plot. From that scatter plot, then you can calculate the strength of that relationship because you will know the direction of that scatter plot. So you will need to calculate the strength to know whether is it a weak relationship or a strong relationship. And that's where correlation is all about. Where the scatter plot gives you the direction, but not only just the scatter plot giving you the direction, also when you do your correlation analysis, it can also give you the direction because the sign, whether it's negative or positive, tells you the direction of how your relationship looks. And then the strength, which is the actual value or the number, which is in decimal format or in a percentage, tells you whether you've got a weak relationship or a strong relationship or no relationship at all. So if we have two numerical values and we put them on a scatter plot, we are able to see whether they've got a linear relationship. The first one tells you that they are positively related. Therefore, there is a relationship which is positive because when the values of X increases, the values of Y increases. Sometimes it can be a negative relationship, where you see that when the values of X are increasing, the values of Y are decreasing. Or it can take up a Cavalier relationship, which if you come from the maths background, this is what we call a quadratic equation or a quadratic relationship. Or it can take an exponential relationship. And this probably at the early days of COVID-19, when the Department of Health was doing all the stats, the COVID-19 daily infections, they will use some sort of a curve that looks like this, which is an exponential rate curve. So it also tells you the relationship that your data is growing exponentially. Yes,
Sorry, are you on the first slide or the second slide?
I am on I don't know whether it's the second slide. Are my slides not moving?
I'm still on lesson overview, unless it's me. Okay, there we go. Thank you.
Okay. So sometimes you can also display your two numerical values, and the relationship does not exist because then the data points are scattered everywhere else. Or otherwise, the scatter plot, the data points are constant over, yeah, maybe on the y-axis or on the x-axis, the value is always constant, is the same throughout, as you can see with the second graph as well. So therefore, it means, yeah, we don't have the relationship between your x and y variable. So when calculating the coefficient of correlation, where we need to find whether those relationship, we know that it's negative because it's going down, or it's positive because it's going up. In order for us to find the strength, we need to calculate what we call coefficient of correlation, and it's always denoted by a value of a letter R. And this tells you the strength and the relation and the direction of the relationship that exists between the two values. And it is always between -1 and 1. So it can never be 2 or 3 or 4 or -2 or 3 or -5. It's always between -1 and 1. If the value of R when you calculate and it is it is greater than 0, we say that the relationship is positive. Therefore, it means when the value of X increases, the values of Y increases as well. If it's less than 0, we say the relationship is negative. When the value of X increase, the value of Y decrease. If your value of R is equals to 0, then there is no relationship. Therefore, there is no correlation between your X and your Y values. Sometimes when interpreting, because 0 and 1 and all that, you need to know what is the strength of that relationship. So this is just the range that you can use. If the value is exactly equals to -1, then we say, how we interpret it, we will say it is a perfect negative linear relationship. And if it's +1, we say it is a perfect positive linear relationship. If it's -0.7, we say it has a strong negative relationship. -0.5, we say it's moderate negative relationship, and so forth, including also when you look at the positive. But sometimes you find the values that are like 0.8, 0.55, 0.35. You need to also make sure that you know what the range might be in terms of how you interpret that. So sometimes we can use a scale to interpret that. So this is just also a demonstration of the correlation value that we have. If we have calculated it, the graph will look like this. So for a perfect positive relationship, it means all the points are the straight line going up. Therefore, it is a perfect positive relationship. If the data set is the data points are scattered all over, and you calculate your R and you find that it's 0.18, then we say it's a weak positive relationship. And it's a strong positive relationship, a negative strong relationship. However, I see that I don't have that graph that also shows you the range between the values. But that's how you will interpret it, because from different R values, let's go back there. Let's say you get a relationship of 0.15. 0.15 is closer to 0. You can always say there is no relationship on that one, or sometimes you can say there is a weak relationship. And if it's positive, you will add also positive relationship. Okay. You are also expected in your module to know how to calculate your coefficient of correlation using the sum square measures. And these are the formulas that you can use to calculate your R. I'm not going to dwell too much on the sum square measures, but if they ask you to calculate the sum square measures, then you can use these formulas. Usually they will give you all the relevant information. Maybe they will give you the summation values and all that. You just need to substitute those values onto the formula and calculate your coefficient of correlation. And if you use the sum square measures, you also need to know that the sum square measures, they also can give you what we call a total variation, which is also made up of two parts. A sum square or a total sum square measures is made up of the sum square measures of regression and the sum square measures of errors. If you combine both of them, they will give you the total variation that is accounted for in your correlation as well. And this is the formula also. Bear in mind, all these are just formulas. So this is your y observation minus your mean squared. Is the sum of your y observation minus the mean squared. In the exam, they will not expect you to do the calculations manually. They will give you all the values that you will need. You can just substitute into the formula and calculate. And this is the estimated value. We will talk about the estimated value later on when we do the regression. This is the estimated value of your y observation minus the mean squared, which is the summation of it. And the SSE is the summation of your y observation minus your estimated observation. And this just gives you the errors that you will have. And you square the answer to it. I'm not going to explain this again. We already spoke about the total variation. Okay, so if you have your R, which is the coefficient of correlation, you have calculated it, and we're gonna do the calculation just now. If you have calculated your R, you can then find your coefficient of determination, which is your R squared. So if you have the value of R, you just put x squared to it, or you take it to the power of 2, and that will give you the coefficient of determination. And a coefficient of determination, you can also calculate it using the sum square measures, because it's just your SSR divided by your SST, which is the sum squares of regression divided by the sum squares of total, or the total sum squares. So the coefficient of determination is actually what we call a portion, or how we interpret it. We're going to be interpreting it in terms of a percentage. So because it will be a percentage, it is the portion of the total variation in the dependent variable that is explained by the variation in the independent variable. So when you get the value of your R and you calculate your x squared, let's say your x squared is 0.60, which is 60%. How you will interpret it, you will say 60% of the total variation in the dependent variable, it is explained by the variation in the independent variable. That's how you will interpret the coefficient of determination. You don't interpret it the same way as you interpret the correlation, because it doesn't talk about the relationship. Here it talks about the variation that happens when you do your estimations that exists between your actual, your dependent variable and your independent variable. So always remember the total variation in the in the dependent variable, which is your y, is explained by the variation in your x, which is your independent variable. Okay. We already spoke about that. The R squared is your square of your regression coefficient of correlation. What we haven't spoke about is the value of your R squared is always between 0 and 1. Whereas with the coefficient of regression or coefficient of correlation, the values of R are between -1 and 1. For R squared, the values are between 0 and 1. So how we interpret, I've already alluded to this. So if your R squared is 1, we say there is a perfect linear relationship, because our R will also be equals to 1. Then we say there is 100% of the variation in Y is explained by variation in X. If the value is between 0 and 1, so let's say it's 60%, we already did that example. We can also say some but not all variation in Y is explained by the variation in X. And if your value of your R squared is equals to 0, we say the value of Y does not depend on X, so none of the variation in Y is explained by the variation in X. So let's look at this example. Suppose that the correlation coefficient of a person's salary and his education attainment is equals to R is equals to 0.6395, which is 63.95. If we need to calculate R squared, we can determine that the coefficient of determination is 0.6395 squared gives us 0.4090. And when we interpret this, we say we can explain that 41% of the variation in the person's salary can be explained by the variation in their educational attainment. And that's how you interpret the R squared. So now let's move on into the regression. Now, we've learned that we do have a relationship that we can visualize on a scatter plot. When we talk about the regression tells you two things. It has the constant value or the intercept. The intercept is that value where x is equals to 0. So it is the value that will pass through your y-axis in a way. If your value of x is equals to 0, that will be the value of your intercept. It also tells you the slope, and the slope tells you the direction. So if I look at this, we are able to draw a line that follows the dots, and that is my line. And this line, it is what we're going to be calculating, and it is what we're going to be describing, the regression line, which tells you the trend of this relationship. So regression line is used to predict a value of a dependent variable based on the value of that independent variable. So it means if I don't know a value that is here on the x value, so if I don't know this x value, I can estimate what the next value at this point can be. It might be there because this is a positive slope. It says when the value of your x increases, the value of your y increases, and we can use the value of x to estimate what the new value of y would be, and the value of y might be there. And that is what regression is all about. It's using the data that you have to predict the new value of your y value using your x values. Okay, so it also helps to explain the impact of changes in an independent variable on a dependent variable. And that impact is what we're going to also be able to calculate, which is called the slope. We're going to do that just now. Now, dependent variable, which is the variable that you want to explain, which is the y, it's your dependent variable. Your independent variable is your x variable, is the variable that you're going to use to predict the y variable. And when we predict the y variable, then we're going to put the y hat on top of the y variable so that then it becomes the predicted value. At the moment, these are just your actual values. The minute we predict the new value, we put it a y hat to create a predicted value. So you will see with the regression line. So the formula to calculate the regression equation or the regression line is y hat is equals to b0 plus b1, where y is your estimated value of y, which is the estimated or the predicted value, and your b0 is your estimate, and b1 is your slope. We are going to calculate b0 and b1, where x is just your observation. So When we have this regression line, we are able to look at the relationship that exists between your X and Y, because it is described by this linear relationship or this linear function. And your B1 tells you, it will give you the changes in your values of Y that are assumed to be related to the changes in the values of X. And your B0 will be the estimated value of Y if X is equals to 0, because if I put 0 on X, then Y hat will be equals to B0 value. And we already explained what the B1 is. It is the estimated change in the average value of Y as a result of 1 unit increase in the value of X. And that is how we're going to interpret the B1, which is the slope. So you're going to say for B1, if let's say the value is positive 0.6, we will say there is an average 0.6. I can't even remember now what value I used, but let's say it's 0.6. 0.6 of Y as a result, or there will be an increase because it's positive. So if the value of your slope is positive, we say there is an increase. If it's negative, we say there is a decrease. So there is a positive increase, or there is an increase in the value of Y as a result of 1 additional unit change. So what we're saying is, on a regression line, for every unit increase, because this will be the value of your X1 and X2. If you move 1 unit from this point to that point, you will be able to calculate that change, because also this will be the change from Y1 to Y2. And that change is just with incremental of 1 unit. So if it's positive, we say there is an increase. We will say there is an increase. If it's like this, it's negative, we say there is a decrease. So you will say there is a decrease in the value of Y as a result of 1 unit increase in the values of X, because when the value of X increase by 1 unit, the value of Y decreases for that one. When the value of Y increase by 1 unit, the value of when the value of X increase by 1 unit, the value of Y also increase. The regression line will be about. So let's look at this example. We've got the test score for new employees and their supervisor grade after they've done the work. So we can then take their pre-test score that they received and the supervisor grading, and we plot them onto a scatter plot, and we can see that this is a positive relationship, because when the value of X increase, the values of Y increase, with one of the value being an outlier, which is outside of the norm. Okay, so we can take these values and we already did the scatter plot on it, but we can also calculate the coefficient of correlation. And calculating the coefficient of correlation, we know that the coefficient of correlation will help us with understanding the strength of that relationship. And to do that, because there are formulas which I didn't bring to the fourth, I should have first showed you the formula to calculate the coefficient of correlation before I bomb you with the table. Yeah, let's go one step forward. So this is the formula that we need to use to calculate the coefficient of correlation. It's very complex, it's very long, but we also remember there is the sum square measure one. So this is the easiest one. So if I have this formula, I know that it is n times the summation of your X times Y minus the summation of X times the summation of Y divide by the square root of your n times the summation of x squared minus the summation of x squared, n times the summation of y squared minus the summation of y squared. Now, this is the same table as I showed you previously. So from this, the data from the grade and the supervisor are here. We calculate the total. So when we calculate the total, remember the total is the summation. So 15 is the summation of x. So this 15 is the summation of x is equals to 15. The summation of y is equals to 45 because we would have added all the values. And from the summations, we can calculate x bar, which is the mean. The mean of x is 3. The mean of y is 9. See? Easy. To calculate x minus the x bar, which is not part of this, I'm going to skip them. But this is just saying your x value, 1 minus 3, it's minus 2. 3 minus 3 is 0. 5 minus 3 is like that. Also similar will be for the y, where you say 4 minus 9 is minus 5. And like that, then go and do all of them. I'm interested in the summation. So to calculate the summation of x and y is just x times y, which is 1 times 1, 1 times 4 is 4. 3 times 6 is 18. 5 times 10 is 50. And when you get to the end, you get the summation of x and y, which is 145, which is the total. The summation of x, we calculated it. The summation of y, we calculated it. The summation of x squared is just saying 1 times 1 is 1. 3 times 3 is 9, or 3 squared is 9. 5 squared is 25, and so on. The same will be with the y squared. You will do the same. The summation of x squared, we're going to take 15 and then we square it. It's not the same as summation of of x squared. All right. So from here, we can then just substitute onto the formula all the summation values, and our n is just counting how many values we have. 1, 2, 3, 4, 5. And you just substitute onto the formula and you calculate your R, and you find that your R is 0.32. Now, this is if you are calculating your R. If you're calculating R squared, you just going to R squared, you are just going to say 0.32 squared, and that will give you your R. So you will just say 0.32 squared, and your R will be 10.24. Yeah, 24. It's 0.1024. And that's how you will calculate your coefficient of determination, your coefficient of correlation. It doesn't end there. Sometimes it's easy. When it's given to you in an Excel, you can take the values, your X and Y values, the way you see them, only those values, plug them in, go to the data analysis panel, select correlation or regression, and do the regression calculation. Input your X and Y values and click on regression, and this will be the summary that you get. Now, on the output from Excel, you will get your R, you will get your R squared. As you can see, those are the values we calculated before, 0.12, 0.32, and 0.10. And those are the values that we calculated. Okay, now, we're going to also look at the regression line. So we remember our formula for the regression line was y hat is equals to b0 plus b1 x. And we said b0 is your intercept and b1 is your slope. Now looking at this, therefore, this will give you the regression line, B0 and B1 value for your regression, and we're only going to take the coefficient values, as you can see there. And that's not it. Alternatively, if you don't want to use Excel, then you can use your calculator. Oh, we already touched on that. So this, then you convert it into your regression formula by substituting your B0 with your slope, your B1 with, sorry, your B0 intercept with the intercept value, and your B1 with your slope value, and your test grade is your X. Okay, so how do you interpret this? So to interpret, remember the two, how we interpret. So we will only interpret the value of B1 of the slope, because remember, your intercept, it is where X is equals to 0, it will be that. So we will assume that if the test grade, if someone didn't score anything, then their supervisor grade will be 7.12. If we're looking at this information that we have, we can say the slope of 0.25 tells us that the mean of the supervisor will increase because it's positive by 0.25 on average for each one additional unit of that test grade being added. So it means for the supervisor grade, it will increase. So if the test grade was just one unit added, it will increase by 0.625. That's all what it says. If this was negative, we would have said it will decrease. So this would have been a decrease. Okay, so far you've learned the regression analysis, that it is used to predict the value of the dependent variable. You've learned the meaning of the slope and your intercept, and we learned how to calculate the slope, the correlation, and all that. But it doesn't end right there. I'm going to show you also how to use your calculator. So because I don't have my Casio open, so we're gonna use this one as an example. So we have our X and Y values, so we need to capture them on a calculator using the state mode. So the first thing that you need to do is to go and press the mode function or the mode button to get your calculator to state mode. And if you do have a Casio calculator, you can follow, so that then you are able to know, and then you can also practice on your own as well. So you will press the mode button, which is that function that is on there. And then you will get a menu bar that looks like this. You will need to press 2 for state to put your calculator to state mode. After you have done that, you will get another menu that looks like this. Previously, when we did how to use the calculator for the descriptive analysis, we pressed the 1 minus var. Now we're going to press number 2, which is a plus bx. Bear in mind, always remember that the value which is closer to the x, it's also what we call the slope. So on your paper, you can write y hat is equals to b0 plus b1x. And you can also translate it into your calculator function, which is a, because that's what you will always have to remember. If they ask you to calculate the slope, what is it that you need to press? Plus bx, which is the slope. So intercept and slope. Don't forget that. So we're going to press 2. And once you have pressed 2, then you're going to press, you're going to enter your data onto your calculator. Now your calculator will be ready for capturing, you will have a table with 2 columns, X and Y. The first thing, we need to put the value of X first, and then we go and put the value of Y. So to put the value of X first, we're going to press 4 equal, 2 equal, 6 equals, 4 equal, 3 equal. Then we're going to use the arrows and go to the right, and then go up, 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 up until you get to the first one, number 1, and then you start capturing the until you get to the top, which will be your number 1 value that you've captured. You're going to enter 5 equal, 3 equal, 7 equal, 6 equal, 5 equal. You need to make sure that when you capture the values, 4 corresponds with 5, 2 corresponds with 3, 6 with 7, 4 with 6, and 3 with 5. You need to make sure that they match. If you mix them, you're not going to get the right answer. They need to be in pairs. Okay, so once you have entered the data, then you can press your AC button. And once you have pressed your AC button, then you need to press Shift. There is a Shift button. You press your Shift button, and then you press button number 1. And this menu will pop up where it says 1 type, 2 data, 3 sum, 4 var, and 5 reg. You remember we had those summations, the sum of X, the sum of Y. You can find them if you press button number 3. For all the regression, we're going to press button number 5 because we're dealing with regression. So if you want to find your some measures, you will press button number 3. If you want to answer the questions relating to the regression, you're going to press button number 5. So we're going to press button number 5 for our exercise. We press 5. And once you press 5, you get this menu bar where it has 1, which is A. Remember, A is our intercept. 2, which is B. B is our slope. And R is our coefficient of correlation, R. And this 2 is when we use to estimate the value. So when we want to estimate the value and we are given X, let's say 8, we then substitute the value of the estimate, and then we estimate the value of Y. So there is no R squared here. So therefore it means when you have to press R squared, you will have to find the value of R and then press X squared button. So to get R squared, you press 3 and then you press X squared. That will give you the value of your R squared. And that's how you use your calculator. Unfortunately, I don't have a Casio calculator. So you can take a screenshot of this and then practice on your own. Okay, I'm going to move to the next one, which is a sharp calculator. Those who have a sharp calculator, I do have a sharp in front of me. I'm going to use it to follow the same instructions that are on here. Okay, so we use it the same data as that. And I'm going to also, before we start, I'm going to also write the formula. Y hat is equals to B0 plus B1X. And I'm going to say Y hat is equals to A plus BX. I'm going to write it like that. And I'm also going to put intercept. And then I'm going to put slope. Okay, so now let's go to our calculator. We need to put our calculator to state mode. So you press mode and then you press 1 for state. And the descriptive analysis, we used 0 for that 1 unit. Now we're going to press line, which is 1, and our calculator is on state 1 mode. Now we are ready. So on your Casio, you must always remember that you are not going to see the table. So you need to be very careful when you enter the values. So we are going to enter the value of X and Y simultaneously by using the STO, which is this button, and the M plus. Not the M plus, but the M plus button. So how we do that? We say 4 store 5 M plus, and then you say 2 store 3, and you say M plus, 6 store 7 M plus, and you say 4 store 6 M plus, 3 store 5 M plus, and it will say I've got 5 data set, 1, 2, 3, 4, 5. It means I've got all of them on here. Now the next step, once you have entered your data, you can then press the on and off button, and it will go back to your state 1 mode. Remember, the data is stored on your calculator. With your sharp calculator for regression, it's easy. All the values are written in green. You will see the summations. They are all here. Sum of X squared, sum of Y squared, sum of Y, sum of X and Y. So you can find all your summation here. You can find your mean of X, mean of Y, your standard deviations for the sample, X and Y. The buttons that we are actually looking for is the open bracket. You will see that A, actually our A on this one is small a, and our B. So do not use those capital letter A's and B's on your calculator, on your sharp calculator, sorry. A and B. So on this one, we use the small letters. So A on an open bracket, B on a closed bracket, and R is on the it's on the division. Now, if we want to estimate, we are going to use the shift button, and we're going to press the X estimate and the Y estimate on the open and close bracket. And I'm going to show you just now how to use that. Okay, so now let's find our A. So we press alpha, and then we press A, and we press equal. And that is 1,659. 1, oh, that's what I did here. Y hat is equals to 1,659. And then to find our slope, we say alpha, open bracket, equal, and our slope is positive 0,93. So it will be positive 0,9332. And that is our regression line. And don't forget to put X at the end. If it's not X, it's something, let's say it's age, then you put age in the place of X. If it's price, then you put price in the case, or quantity, you put quantity in the price of X. Okay, so that is how you will do your regression. So let's calculate our R quickly. to calculate R on and off, alpha R equals 0.9332. 0.932. And let's calculate our R squared. And our R squared will be R squared. We'll just press the X squared button and then equal. And our R squared is 0.868. 868. 0.868. So let's interpret the with a 0.932 estimate value, or there will be an increase on the value of y. Yeah, there will be, for every value of y, there will be an increase. There will be one additional unit increase in the value of y, right? And then our R squared is 0.932, so therefore it's positive. We say there is a strong positive relationship between x and y, and the value of our R squared of 0.682, we say there is 87% of the total variation in the values of y is attributed by the value of x. Right. So that's how we will interpret the slope, the R, and the R squared. For the intercept, you just say if the value of x is equals to 0, then your estimated value of y will be equals to 1,695 or 1,659. And that's how you do it. So if you have a financial calculator, it works almost similar to the Casio calculator. You can, not the Casio, the Sharp calculator, you can follow the steps, but instead of using STO, you can use, there is those two buttons. There is an ENT and the X and Y button. So you use those two buttons to enter your data. And on that note, that concludes today's session. We're not going to do any activities. Are there any questions? Is it too much? At least it gives you an idea of what to expect in your study unit 11. Is it 11 or 10? 10, since you're doing, yeah, study unit 10. In the absence of questions, then we're gonna call it a night. Have a lovely evening. Good night. See you on Saturday when we do the relationship between two categorical variables. And that will be the last session that I will have with you. It was a pleasure. Good night.
Good night. Thanks, Lizzie.
Nice.